Welcome everyone to another Synology Partner Online training. I'm Jeremy and today I'll be taking you over Savant Station for large-scale deployments. So this is actually the third in a series. The first two were done by my colleague Satyam. One was more of an introduction to Savant Station, and the second one more for small businesses like shops, how you can leverage it to create a cost-effective Savant system. Today we're going to be looking at large-scale deployments, and we'll be introducing this webinar around a bit of a methodology, looking at best practices to answer questions, typically what are the key settings I need to look into, what are the best choices to, realize a very cost-efficient and resilient system. And notably, we'll be zooming in on CMS, Central Management System. It's a key component of our station. We'll look at the setup and a key part, which is the failover. That is what brings resilience. And all throughout, we'll try and put as many numbers on things to give you the best insight, the best information, notably how certain settings will impact the bit rate, therefore load your network. And also we'll try and see how fast a failover can happen. Just before we jump right in, a word about the surveillance market. So, particularly on video analytics, that is really driving things until 2025, an estimated 19% KGR. Interestingly, this is driven by on-premise and server-based solutions. So, I guess that's good news for Synology. That's what we do. In terms of areas, sectors, there's quite a few, but retail really is at the forefront, and obviously that's another area where we're quite well implanted. Now also the retail sector often can have large chains, and therefore a clustered, a distributed solution like the central management system that we'll be looking into can really be, again, a great and compelling solution for those types of customers. So Synology Savant Station is already quite a mature solution. We've been developing it since 2008. We've also had dedicated hardware to expand its capabilities, visual stations, NVRs, and recently to take advantage of the trend on deep video analytics, which really boosts the productivity of businesses, the DVA 3219. Savant Station is trusted by some very key customers out there. Camden Market in London, Holiday Inn, Unilever, there are others, and we'll be taking a look at some of these case studies to see how these customers have implemented it, and again, to improve not just productivity, but also reduce the cost on their surveillance installations. So without further ado, let's get into today's session. And as I mentioned, we've tried to build it around a methodology looking at best practices, and we also want to answer some common questions we get from customers. What's the maximum number of cameras that you can host on a Synology? Well, we're actually going to see it's actually more in terms of cluster of Synologies that you need to think of. What bandwidth will X number of cameras require at 1080p? We'll look into that, and other aspects such as, if a server goes down, how long does it take to recover it from failure? So the methodology is built around 5 key steps. The first 3, which we'll spend most time on, are around the server, so starting from defining your requirements all the way down to the details per server and the design diagram of the entire system. And the last 2 are around the client, so the viewing devices, as well as the cameras that you're going to choose. So step 1, what are your requirements for the feeds, whether it's for recording or live view monitoring? Obviously, aspects such as the resolution, the codecs will have a big impact on the bitrate, the amount of bandwidth which is going to be required on your network. So when you're doing this, I really recommend you check out a great tool on our website. It's the NVR selector. Some parts are quite straightforward, number of cameras, the days you want to store. Then there's more advanced aspects such as the format that you want to choose, the resolution, the frames per second. And with all this information, you get an exact recommendation of the unit that you're going to need. It's important when you get the recommendation to not just check out the units, but also this aspect here, particularly bandwidth and obviously total disk space, and also the devices that will be able to handle the viewing of all these cameras. Now, Obviously, the tool's quite straightforward, but you may be wondering, well, what's the difference between the video formats? Which one do I need in which scenario? So I'd like to take two, well, potentially like extreme ones, but so you really get the idea. We'll start with I don't know, a type of scenario where you need to do high level analysis. You need a lot of precision. Now think on a motorway, a camera which would be doing number plate reading, or I don't know, in an area like a casino, a bank, you want to be able to monitor everything without overlooking a single frame, or maybe an area where you've got dark, bad weather conditions. So there, frames per second need to be pretty high. I would say don't go under 25. Codecs, if you can go with MJPEG, that captures every single frame. So it's a bit heavier on the storage and the network, but it's the best for, like, think of a photo finish on a race. You get every single frame and you can analyze at the best possible level. And finally, resolution 1080p or potentially higher. There are cameras with, I think, 5 million pixels. So if the camera supports it, you can go with that. Now, sometimes you may not need that level of precision and you'll be wanting to reduce the amount of bandwidth and storage used. So think of maybe at home a baby monitor. Now, this is obviously a topic on enterprise deployment. So think maybe of the entrance of a building. You just need to be able to know when someone is arriving, and then maybe in the hallway you've got cameras where you want to actually do more specific viewing. So just for the entrance, you could go with lower frames per second. 10 would really be the minimum. There's been studies done when you go like to 8, 7, 5, you miss too many frames, and then the error rate can go up to easily 60, 70%. Codecs H.264, much lighter on the network and the storage, and resolution 480 to 720p is something you can consider. So I just want to illustrate this a bit, and we've said, so for instance, dark, bad weather conditions. Well, I did a test in the office, so everything's going to be equal, all the settings, none of them are going to be changed, and under normal lighting conditions, you can see bitrate is 519 kilobits per second. Now, the same at night, you can see obviously it's become quite dark, and the bitrate is through the roof, over 10,000. So you can see here we have a factor 20 now. Bear that in mind when you're building your system. That could have a big impact on the network, and therefore, well, keep that in mind. That's an example of variability. So how would you go about mitigating this variability on the bandwidth? There's an important setting, so CBR, constant bitrate, as opposed to variable bitrate. Now, another example that was shared a few years ago by a colleague in HQ who had a customer who had that problem. They'd spec'd out everything for the school while it was empty. Well, I think it was still being built. And when actually the students, the teachers, went to work and were in the corridors, then I think it bumped up the average bit rate by a factor 4. So the lesson from that is to really, take into account the screen complexity, the motion that you're expecting, apply the right buffer, and with constant bitrate, that means you'll be able to, avoid having a bad surprise. You'll be able to choose your network equipment, the switch, the routers in advance. One thing I want to mention, that's point 3, is that constant bitrate, when you use it with H.264, you may in certain circumstances have an issue. It's that with very high resolution scenes, there may not be enough bits to encode, and therefore you're going to see a bit of a loss of quality on those frames. So bear that in mind. Most of the time we'll be fine, but if not, try and switch to MJPEG. So that brings us to the topic of codecs. Most cameras will support MJPEG and H.264. I've touched on the fact that MJPEG compresses every single frame, therefore ideal for in detailed analysis. H.264 gets certain frames and measures the difference between the others. So again, most of the time it'll be completely fine for regular viewing, but when you need to do finer analysis, it may not be suited. H.265 is a more recent codec based on the idea of H.264. It brings great advantages in terms of compression using up less bandwidth, do bear in mind that it requires more processing power, so not all cameras will have it. If you're planning on using it, select a camera that has that. And finally, there are what we call smart codecs, Zipstream by Axis, H.264 Plus by Hikvision. Now, a good example here, you have it, rather than getting high quality on the entire frame, you just look at the region of interest, and that means that it's going to be, well, using up less bandwidth. So H.264 and MJPEG, I did another test to see what the impact was. Now, obviously, this is in a specific environment. It may change whether you have, I don't know, more motion or not. But as an example here, everything is still. And with H.264, we're around 550 kilobits per second, 15 times higher with MJPEG. So again, if you can avoid using MJPEG, definitely choose H.264. It'll really save you a lot of bandwidth. Now I'm going to go on to I think a last and really important setting. Now this isn't necessarily going to reduce variability, but it's going to make sure that you're using as little bandwidth as possible, and therefore you won't have a clogged up network and can potentially use more cameras overall. So it's called dynamic stream settings. The idea is very simple. You're going to have live views on standard at as low as you want it, maybe 240p, and only when you have an event that you need to investigate will it be automatically bumped up to 1080p. So that's the idea of dynamic stream settings. So I'm going to give you a demo on how to set it up, show you how it works. One thing you need to know is that a camera for that needs to have multiple streams. So we'll see how to enable that. But if your camera has a single stream, you won't be able to use dynamic stream settings. So here we are. You can see I've got a setup with two cameras. They're actually already, you can see where they are on the map. One I've set up at home. The other one's in the office. And well, what we're going to do is in the office one, we're going to first display some camera information. So we have the bitrate, notably. We can see how that evolves. And I'm going to enter the frame in a few seconds, and well, we'll see what's going to happen. So currently we're around 700 to 800 kilobits per second. That is when things are idle. I enter the view. It's going up to maybe 2,000 kilobits per second. So that's to be expected. But we like the default rate when it's idle to be lower. Now for that we go to the camera settings. We want to enable these dynamic streams under live view. However, before that, as mentioned, we need to stay in device settings, go to the video tab, and set those streams. So you can see under stream profile, we're only using stream 1, okay, for high quality, low bandwidth. But you can see there are 3 streams available on this camera. So we could assign stream 2 to high quality. If you're looking, stream 1 is already set. There's a reasonable resolution, so we're going to keep it on stream 1, and low bandwidth is going to be set to stream 2. And if you scroll down, well, now you can see that stream 2 parameters are available. So I'm going to reduce the resolution even further so that we really save on the bandwidth. Frames per second 10, that's a good minimum. Image quality to the lowest. You could put constant bitrate if you wanted, and now you can save that. It just reactivates the camera. Give it a few seconds. And now that we've done that, we can now go to live view settings. And because we have 2 different streams, well, we can adjust the live view. By default, it's going to be low bandwidth now. Okay, and under dynamic stream settings, only when an event is detected are we going to bump it up to the high level. So you can choose which events you want. Here it doesn't make a difference. I'm going to select them all. You can choose the minimum duration. Okay. Here, sticking to high quality, minimum duration of 10 seconds. You could bring it up to 30 if you wanted. That's completely up to you. So we're saving, we're reactivating the camera, and we're going to move on to the next part and actually test. So again, 47 kilobits. I'm now entering the frame, and you can see after a few seconds it's adjusted the quality, and you can see it's now on the high quality stream. So again, we're only going to be using up more bandwidth when we actually need that to happen. And if we wait these 10 seconds, well, in theory, we should be seeing the quality go down again. So let's just do that. And we're nearly there. There we go. Okay, so back onto the low quality stream and the bitrate is going down again. Now I'm just going to head back to the camera settings, and I'd just like to show you something. Obviously we've done all this for live view, but you may be wondering, well, can I actually do it on recordings? Because that will impact the storage used on the Synology itself. So yes, you can. You just go to recording settings, stream, and the same, you choose event detection and the profile that you want. So the same thing is available, and they're independent. So you can really do what you want with the live stream and the recordings. You have all that flexibility. Right, so we've gone through the first step. We now look at the the server itself. Questions such as, well, how much processing power do I need? How many bays? Hard drives, which ones should I put in? Do I need 10 gig? So what I've done here, I've run the calculator for two cases. Case one, I only need 58 terabytes. So for a case like that, and imagine it's in an office, you don't want it to be too noisy, go for a desktop such as the 3018XS, six 12 terabyte drives in it in RAID 5, and that's going to deliver the amount of storage. If, on the other hand, you needed 730 terabytes, so you're looking at an enterprise model there, SA3400 with 85, a minimum of 85 10 terabyte drives, RAID 6, enable RAID groups to, in a way, modularize the storage. So again, these are just regular storage calculations. I'm not going to dwell on them. The more interesting part, I think, and can often be a bit more confusing, is the bandwidth. How do you, well, ensure that that's going to be fine? So 2366 megabits per second. First is, well, the network. Is it going to handle it? So you need a switch that's going to deliver. And then in terms of the Synology itself, well, three 1 gig ports, gigabit ports, that's going to be enough. You can bond them and you'll have enough bandwidth with that. You don't actually need to use a 10 gig port if you want to save it for another type of application. Now, because you have the network fast enough doesn't mean that the storage itself can ingest at the matching speed. So for that, well, you need to look at what hard drives you're putting in and how many, and what RAID type you're applying to that. Now, what I always recommend is if the bandwidth is quite high, that use as many drives in the RAID as possible. If you have 12 rather than 6 drives, well, you have more heads to write to, and therefore you get double the throughput. So that's always something good to bear in mind. Now, what I did here is the calculation with 12 SATA enterprise grade hard drives. I think I looked at the Seagate Exos, and then I went on to an online RAID performance calculator, applied a RAID 6, and you can see the writes will be 857 megabytes per second. So we're nearly there. We just need to convert these megabytes to megabits per second, and that is going to be 6,857 megabits per second. So we're way above what we need. Now, it's always good to have a bit of a buffer. Be conservative on this. Remember, we've seen variability can really hammer your network, but that should be a fairly safe buffer to go with. So, what hard drives do you need to put in? So in general with Savance, you don't need SSDs, at least for the recording part. Now, if you're going to be doing a lot of analysis, maybe going through older versions, using the Smart Search, potentially an SSD cache will be beneficial. But again, just for the actual writing and the main pool of storage, you'll be going with hard drives, and you may be wondering, do I need Savance grade hard drives? So we need to understand what these hard drives are, what the manufacturers bring out. They're optimized to be used in an NVR, therefore being able to handle constant recording. So the write-read ratio is 80 to 20. So that is, in a way, good news. However, what you need to look at is it a consumer grade drive, or is it NAS or enterprise grade? So very often they may be consumer grade and therefore desktop grade and not designed to be used in a RAID. bear in mind that a RAID is really going to, in a way, be quite intensive on the hard drive, constantly asking it information, writing the parity. So if in doubt, I really recommend just going with a recommended NAS grade or enterprise. Think of the NAS grade are Reds, Einwolf's N300s, and obviously if it's going to be in an enterprise environment for surveillance, go with I don't know, XARS, WD Ultrastar, Toshiba MG series. Now, until now we've been looking at a kind of a single server. Obviously, if you've got multiple sites, you'll have quite a few of them. You might need a clustered deployment. So it's important to go through a design diagram phase and really look at the various links between the sites, what type of architectures you'll be introducing. So between sites, you always want to make sure that the links have got the minimum level of bandwidth that you're going to be requiring. You also want to build in resilience into the system, and notably on the server level, you want to have failovers and have these automated as much as possible. So this is what we're going to be looking at. An example of a design diagram you have here. I think it's fairly straightforward. It's probably sometimes a complicated process from the fact that there's lots of aspects, especially if you've got a large number of sites. But at the end of the day, it's a fairly straightforward thing to do. And yeah, remember to list out all of the viewing devices, all of the cameras, and how much bandwidth you have in between sites and on site to make sure everything is going to be fine for smooth viewing. I'd like to highlight, so Camden Market, as you know, use Synology Surveillance Station. Now, even though the market itself is in a way one site, because it's spread out, technically they do actually have multiple different locations and a recording server in each one of these, and they do actually leverage Synology CMS. Now, what's interesting there is that rather than rely on a regular internet connection, which could be slow, they've actually made use of fiber cabinets to kind of link the networks of the sites together. So it gives them a single big network, and it means that they have an infrastructure that they control, and they know that they can guarantee that throughput for reasonable viewing and exchanging of the large recordings. So that's a good practice maybe to bear in mind. CMS, Central Management System. Now, what's the key benefit? There are actually two. The first one is central management. It's in the name. You have a host, and everything is managed as well as viewed from that single interface, and that really simplifies your life as an IT admin. So you can have multiple recording servers, even in geographically different locations, but a single viewing device. Now, the second benefit is the redundancy, the resilience of the system. And that means that if a node is to fail, something can take over. Now, one exception is the CMS host. There you actually have to do a traditional Synology high availability cluster, so you have to purely mirror that one with an identical device. But for all the other recording servers, and think if you have 100 of them, you don't want to be duplicating them. That's going to really send your costs through the roof. You can have a certain number of failover servers. It can be a lower number because a single failover server can, in a way, back up or protect multiple recording servers. And what happens is that if a recording server goes down, a failover server becomes a recording server. And interestingly, because you can apply batches, if in this batch you only have low-powered desktops, you can go with a cheaper, more cost-effective failover server. Now in this batch, the biggest and more powerful unit is this rack. Then you want to kind of have this as a minimum, as a backup. And this is typically what Holiday Inn in their CMS setup have gone with. Obviously, you can read the case study more in detail, but again, that gives them a lot of flexibility as well as resilience because they have quite a large setup. And here, I think we are on 450 IP cameras with at least 10 various servers over their multiple sites. Well, without further ado, I think we should take a look at how CMS works. I'll give you an overview of the capabilities. Now, bear in mind, we've got limited time on this webinar. There's a lot you could talk about, but just so you get the key ideas, key benefits, and then you'll see we have a host and two recording servers which are set up. Then we'll add a failover server and see how you protect the other two. And then we'll actually test the failover itself. So let's get started. So here I am logged into the host. You can see the IP address at the top. I'm using the internal IP on the same network. It ends in 1.24. You can easily identify the host that way. Sorry. What we're going to do is take a look at the cameras that we have. So in the live view, you can see the map, the two camera feeds, same as earlier. Now, what's interesting is that actually these two cameras are on two servers which are not this host, and you can see that when you go to the camera list. So there's actually a third one which is disabled. I could re-enable it if I want right from the interface. But then, so all of these are actually, all three are on recording server 1 and recording server 2. They're not actually being run on this host. If you, for instance, click on a specific camera, you can find more specific information about it, the various streams, where the recordings are being stored. So, and again, you don't need to dial into each server individually to find all that out. If you have lots and lots of cameras, you might want to be switching between list view or thumbnail view. You can use categorization by status, by server. You can sort by name, IP address. So again, there's really a lot of things you can do. And bear in mind, if you've got hundreds of cameras, that can really just make the management much easier for you. Now, moving forwards, we are going to be looking at the actual CMS function. So before you enable start CMS, you need to make sure the plugin is installed in the application center. It's a bit like the package center in DSM, but it's in Savant Station. So make sure it's installed on every single host, on the host, the recording servers, and the failover servers, that it's enabled, and then you can start your setup. So again, to save time here, we're going to the CMS package, and you can see that I've got the host and two recording servers ready to go. So again, that's good. That's already there. We're going to be adding the failover server in a second, but again, you can see it's a fairly simple interface. Again, you can see key information about the recording servers if they're locked, and they are locked by default so that people can't make changes to them. You can see the connection method, IP, Quick Connect, DDNS. And so I just mentioned that the recording servers are locked. So I'm going to log into one, go straight to the Savant Station interface. I'm going to log in as admin, and let's see what happens when we try to get in. Let's give it a few seconds to load. Okay, it tells us that we're in recording server mode. So again, you would be able to get to the CMS window, but again, a lot of the key functions will be locked down so that you can't just have people go in and change things that they aren't allowed to do. And obviously, it's the same for the failover servers, which is going to be even more locked down. Right. So in terms of what you can do with CMS, obviously, is view these various servers, add a failover server under the second tab. That's what we're going to do right now. You could add by batch, so that's great in a large-scale deployment. Here we're only adding one for protecting the two recording servers. You will need to start by giving it a name. So we're going to call this one failover. Fairly straightforward, especially if we only have one. Then you choose the connection type. So IP address, DDNS, or Quick Connect. Quick Connect is supported. I would recommend against Quick Connect if you haven't done port forwarding, because it'll go through the relay server and might not be great if you've got heavier streams. Here we're going to connect over the internal IP address on the network, port HTTPS. So if you've customized that, you can adjust the connection method, and that's pretty much all you need to do to add the failover server. So just give it a few seconds to configure. You can see it's a DS1517. You also can see on the right hand side protected server, none, so this hasn't actually kicked in. We'll see in a few seconds that we'll actually want to match it to a specific recording server. Before I do that, I just want to show you the failover settings. So you have the option to enable or disable automatic failover. You have aspects such as server disconnection. So again, that can adjust the sensitivity. You may not want a failover to kick in for whatever reason, because maybe you know that your network is a bit unstable. So again, you have those options. You could set it up to, I don't know, 2-3 minutes if you wanted to do so. Here we're going to keep it down to 1. Storage status, volume crashed, volume degraded. Here we'll be a bit stricter. We'll add more events to trigger. And for the demo I'm going to do, I'm making sure that package disabled is going to trigger that. Then you have the option to have the failover go back to the original once things are fixed. Then aspects such as the failover range, the failback settings, again, all that is stuff that you have control over. So yeah, we're going to save, and I believe it is time to go on with the next part of the demonstration. So as I mentioned, we are going to be testing the failover, but first we need to make sure that the recording servers, and notably recording server 1, when something happens to it, it's going to target our failover server. So you can see here, nothing's been assigned to it. Let's just go to Edit, Advanced, and select. Now if you've got multiple servers, you can choose which ones. You can choose all failover servers. That's completely up to you. Here we've only got one, so problem is easy to solve. We click Save, and there we go. We're ready to test out the failover. So we have the live view. I'm also going to leave the CMS app so we can actually see the status of the servers. And in a few seconds, what I'm going to do is log into the actual DSM of the recording server. So it's the DSM here, and I'm simply going to disable the Savannah Station package. Very simple. As soon as we do that, we'll head back to the CMS. I'll be putting myself in front of the camera, waving a bit, and we'll be able to see how long we are left without a feed. So here we go. The failover should be starting fairly soon. You can see it seems like, yeah, the stream froze. It was detected pretty fast, and so the package is stopped, but that's been identified and it's protected. So you can see from this tab, okay, configuring, that means that the failover has been detected and the roles are in a way being switched, or should I say the failover is converting to become the temporary recording server. Okay, so the camera feed is showing activating. That's always good news. So I've put myself again in the feed, so as soon as things are back, we'll be able to see that. Okay, so here we are. The feed is back, so we can carry on monitoring, and the failover is now complete. So that's perfect. What I've done is I've measured this, and actually it was achieved in just under 41 seconds. So that's actually quite fast for a failover. But I think more important than the speed is all automated. Imagine if that hadn't been automatic, you'd have received a notification, you'd have had to dial in. Imagine you weren't in front of a computer, you were on a mobile device. Again, it's all doable, but it adds precious minutes, and here 41 seconds really gives you the confidence that you're going to lose very little time of both live view and recordings. So This was for our demo. I just want to talk about CMS host selection. We often get this question: how many cameras can you manage with a Synology unit? So I think the maximum number on our most powerful unit is 128. However, more important is that if you leverage CMS, you can actually have a clustered distributed setup. And if you take SA3400, which has an 8-core Xeon, where you can have 300 recording servers and up to 5,000 IP cams. Now, bear in mind, I don't think this is hard coded, but really we recommend sticking to that just for the overall performance and good viewing capabilities. Now, another question we might get is that host server, well, if it can do 120 cameras, is it able to also host cameras itself? So the answer is yes, but we recommend having a third of the maximum, so probably stick to no more than 40 cameras when it's also acting as the host server at the same time. Some other key benefits of using central management system with Synology Savant Station. It's batch management. That's the first one. So we touched on it when we were adding the failover server, but you can also do that with cameras, with licenses. I think our DSCam mobile app can also help with the reading of the adding of the licenses to do that faster with QR codes. Management roles. Now that's not directly part of the central management system, but if you've got multiple sites, you may have local admins, and you may want to have a bit more granularity and flexibility on what you allow them to do. Maybe do local admin tasks without being able to access maybe the host server, because that's not something that you want to give them access to. Then finally, license allocation and migration. Again, that is something that's simplified with a CMS. Now we've reached the end of the first 3 steps. Obviously, always go back to the original requirements. Make sure that everything the decisions you've made are going to allow to meet that before you actually jump into the next 2 steps. Now I'm going to go pretty fast over these. I think they're very straightforward. We've got great FAQs and tutorials on the website, but really choosing the right viewing device and the right cameras is essential. So I'll say a few words on the viewing clients. You can obviously use a regular computer, regular laptop, web browser, or I really recommend a client that we have which gives the best possible viewing performance. We also have our visual stations. Think of them as very basic like computers, but they only do Savant Station. A key benefit of that is that, well, you can't have someone browsing, an employee browsing and potentially downloading a virus. It's really locked down, so it gives a big advantage in terms of security, and they obviously optimize for Synology Savant Station. If you need help selecting, there's obviously that NVR selector, but also a tutorial that explains it pretty much in detail, so do use those resources. Visual stations, so they're often used in large-scale setups. If you're trying to build a kind of a bit of a camera wall, I know Camden Market do that. I think they've got something like 4 or 5 monitors. They've got multiple visual stations, which they kind of pair up with a KVM switch, and interestingly, so you have obviously HDMI outputs, audio outputs, but also aspects such as the USBs mean that you can plug in like a mouse, a keyboard, even a joystick, and that allows you to control things like, for instance, the PTZ of the camera more intuitively. So it's quite a powerful device. Let's quickly say a word about camera selection. Now, if you've already got the cameras, now that is probably going to be one of the first steps in the methodology, and therefore you may not be able to reach the ideal requirements for viewing and recordings that you want, but really try and do that at the end when you can, to make sure that you have everything that you want. And there's a lot of cameras out there. Leverage our compatibility list. It's got a lot of filters that allow you to really narrow down the selection, and then it's going to recommend what cameras are going to match that. Now, I just want to say one thing about cameras, and if you choose the right one with a specific feature, it will allow you to add an extra level of resilience and redundancy, not just at the server level, but also at the camera level. And it's with a feature called edge recording. Edge recording is very simple. If your camera has an SD card, where it means that should something happen on the network, for instance, rather than lose recordings because they're not reaching the server, they'll temporarily be stored on the SD card. And when things are back up and running again, the recordings will be transferred over to the server. So that's a really good feature. In a business environment, do leverage that and think of it when you're selecting the camera. And I think if it's not on a camera which has been tested by our engineers, actually, if the camera supports a specific OnViv profile, I think it's Profile G, well, you can still make use of it through of that feature edge recording through Synology 7th Station. Right, so we finished the whole methodology. Just a reminder, first three steps on the server. Really, it's important that you define what your goals are in terms of the monitoring feed requirements. It has big impacts on the potential bandwidth and amount of storage needed. Then you choose the server, then you do your design diagram, then your clients and cameras. So just to recap, what we've looked at today are best practices and presented through a methodology to help you build a cost-effective and resilient CMS centralized management system. We discussed key settings such as dynamic stream settings that can really help you reduce the impact on your network. We also had a look at how to actually set up the CMS, and we measured the time for failover. So remember, that was just 41 seconds. We also had a look at, what impacts bitrate, therefore bandwidth. So remember, bad viewing conditions such as the dark or motion detection. So really try and keep that in mind when you're speccing out, when you're designing the system. Really always build for the worst case scenario. That means that you'll always have like a buffer built in, and you won't be needing to scrambling to add more powerful switches or more powerful servers later on, which will impact your costs. Just to finish, I want to mention so that DVA 3219. Now that brings advanced video analytics. It makes the whole system even smarter with this graphics card on board. It's server-powered AI video analytics. Nothing goes to a third-party provider or cloud service. There's been a recent update, Synology 7th Station 8.2.8. It's not dedicated to the DVA, but there's a key feature, facial recognition, has been brought, and the DVA takes complete advantage of it with its graphics card. So it now means that in 7th Station you can do you can now do facial recognition, and that is good news. So to give you one example, what we mean by smarter analytics, think of these guys. In this environment, we may be enforcing wearing a mask. It's going to be able to detect that, and in a hospital, for instance, it would be able to flag someone not wearing it. Whereas the opposite in a bank, when someone enters with a mask on, you might want to flag the opposite. So again, that shows how smart the analytics can be and how they can really help your your people in charge of monitoring the premises. Finally, I want to highlight that we have some pretty exciting webinars coming up. So there'll be one in mid-October on the DVA 3219 done by my colleague Joe, but we will also have building a small business server and optimizing storage performance. Notably, this one is a repeat backed by popular demand, so these are coming up in September. So I'd like to thank you all for listening to this webinar. If you have any feedback, any comments, you can email them to us at uk_sales@synology.com. And if you like this, you can also leave a comment on the YouTube channel and like the video. So thanks very much, and see you in the next one.